just regarding the discussion in the comments about the earthing of this frame and the pot here. I've got my multimeter connected up to the negative lead of the multimeter is connected up to the earth wire coming from the mains socket. Here in New Zealand, every power outlet has an earth terminal, so that's what I'm using. And the positive is connected to the frame or the case of the power supply, and that's a difference of 37 volts there with the motor off. And when I turn the motor on, it goes to about 48. So I guess I'm supposed to connect the earth to the frame to stop that. I don't know. I'm going to have to read up on the net before I do something stupid again. So let's see what the voltage difference is between earth and this potentiometer case. So this is about 5 volts with the motor off, and let's see if it changes. Now it goes up to 37. Oh, well. Why is it jumping around? Well, there is a voltage difference between this and earth, which is the main point. Alright, so I'm going to try this. The earth wire from the mains is connected to the case on that screw there, and then on the other side we have that screw from the case going to the case of the potentiometer there. So hopefully we're not going to blow anything up this time. Alright, maybe that will be a little bit safer. I managed to find one of these whole setups here, the main board and all the drivers and everything, on Trade Me here in New Zealand. So I got that in 2 days instead of waiting for about 2 weeks for it to come from Banggood. And it didn't cost that much more either, so I might actually get some of the stuff from that place on Trade Me from now on. Anyway, so I put it all back together, and of course now the Arduino is not connected to the power supply unit at all. And I measured the voltage potential between the ground pin of the potentiometer input and the ground of the Arduino, and it's around 30 volts, sometimes 40-ish. So that, I think, was my problem before. So I'm not going to be connecting them directly anymore, but what I thought I might do is try something as suggested in the comments and use an Opto-isolator. In this case I'm going to try this laser. This one here is like a laser pointer thing, and this one is a laser receiver, and it's basically just an on-off switch, but the PWM coming out of here is an on-off switch anyway, so that's okay. And then over here I might try smoothing it a little bit, which I'll have to set up now. Let's go inside. So if that all works out, we should have the same square wave input coming into the receiving side, and it may be possible to give this directly to the power supply unit, so switch it on and off 7,000 times per second, or almost 8,000 times per second. But just in case it doesn't like that, I thought I would add an RC filter on here to smooth this wave, or basically average it to between the top and the bottom. And that would also allow me to make the voltage on this pin rise and fall slower when we're changing the voltage. So it's almost like a human is turning the dial instead of having a machine turning it off and on immediately very quickly like this. So I've been playing around with this for a while. I've just got a quick test set up here. A 20k resistor and a 10 microfarad capacitor. So let me just change the scale. Whoops, wrong way. Scale here so that we can see this in a little bit more slower movement. Okay, so that's it there, going from top to bottom, but if I move my scope pin to the other side of the resistor, we see that it's smoothed and it's averaging between the top and the bottom of that square wave. And now when I change the spindle speed, let's turn it off. You can see it takes about 1 second for it to get to the settle on the voltage that it's going to as its destination. So let's try this. So that should be a little bit more like the dial behavior that it is used to. So that's what that's going to look like when it's done. Well, it is done. And the white wire is the signal wire coming in from the laser receiver. Red is the power wire for the laser receiver. So at this end it looks like that. Okay, so everything's connected up there, and that's the receiver sitting there, and I have my transmitter just powered. It's fully on at the moment, no PWM at this point, but let's just plug in the mains for the power supply unit. Right, so now when I shine the laser on there, it should start the motor. That's the idea. Doesn't work. Oh, it is working. It's very slow. Cool. Just got to hold my hand still probably. I don't know if you can hear the motor, but it's spinning quite slowly. I don't know why it's not getting up to full speed. It sounds like it's spinning at about a quarter speed. Strange. Well, although it's working, it's not turning the motor at full speed for some reason. So it's going to be more of a nuisance than it's worth at this point. So I think I'll just forget about this, and I'll put the potentiometer back on, and I'll just use that and set the speed manually. Okay, so I've reverted back to using the potentiometer to control the motor power supply directly, and that works, but I'm having a very serious problem in that it stops the Arduino from working still somehow. Not with fireworks, just with invisible problems. So you can see everything's working now. Then as soon as I spin the motor up just a little bit, I just spin it up for a second and then turn it off. Oh, now it works. Hold on. Spin it up a bit more. Yeah. And now I've completely lost all control of the Arduino and the stepper drivers. Nothing's responding. So what the hell is this all about? The only thing I can think of is that maybe this wire that powers the motor is somehow making a connection through the whole chassis of this frame and going into one of the stepper motors, and from there back to the Arduino, and we're having another sort of a voltage differential problem like we had before, just not quite as exciting. So what I'll do next is I'll try disconnecting the motor wire, and I'll turn the dial again and see if that makes any difference. Yes, that's what it was. So if I disconnect one of the motor output wires like that so that there's no power going to the motor, then I don't get that problem. Okay, so I've been measuring some potential differences between some spots here, and I'm still none the wiser about what I'm supposed to do. If I measure between the case of the PSU and the ground of the Arduino, 114 volts AC. If I measure between the case of the PCU and the case of the motor, 98 volts AC. And then if I measure from the ground of the Arduino to the case of the motor, the spindle that is, about 10.6 volts. This is with the power supply off. I mean, it's on, but it's not, the dial's not turned up. So between the spindle and the Arduino there's 10 volts now. But when I turn it up to about halfway, I've still got one side of the motor cable disconnected, but that seems to be enough to upset it. So now the voltage potential between the spindle and the Arduino is 29.9 volts. So it seems to be that is what's messing it up. Resistance between, say, the spindle and the Arduino ground Oh. Oh, it's not giving me any connection at all. That's funny. It was before. So it's 270,000 ohms between the spindle and the base of the machine. So there's a slight bit of connectivity there, but not much. So what the hell am I supposed to do here? So between the Arduino and the spindle at the moment I have either 10 volts or 30 volts when it's on. But if I connect, well, see, what I thought I was supposed to do was connect the case of the power supply to the case of the spindle. But that would give me 100 volts difference between the Arduino and the spindle, which is worse. So, what the fuck? What do I need to do here? I don't want to blow anything up anymore. I'm sick of waiting for things to arrive.